So we just looked at graphing quadratic equations and graphing them using transformations or by finding the vertex and X-intercepts if they exist and Y-intercept. Now we're going to jump into looking at quadratic functions and inequalities. So there's a couple ways that we can do this. And so one option, let me just read through this. One option, you're going to rearrange the inequality so that 0 is on the right-hand side. You're going to graph this f of x equals ax squared plus bx plus c using the vertex, axis of symmetry, x-intercepts and y-intercepts. So once you've graphed it, you're going to use the graph to determine the solution set. So it depends on what type of inequality you'll have. Is it greater than or less than? So if you're solving an inequality that has a greater than sign for that quadratic, the solution set is the values where your function is above the x-axis. That is where f of x is greater than 0. So your y values are positive on the graph. You're going to look at the x values that give you that. So for instance, let's say that we had some graph and let's say it looked like this. And we want to find when f of x is greater than 0. And let's say that these values right here, let's say that this is -2 where it's crossing. And let's say that this is 3 where it's crossing. So we're looking at all the x values that are going to give us the y values that are positive. And so notice our y values are positive in here, right? And over here. So the x values, we're going to look at from -infinity coming into -2. Since this doesn't say greater than or equal to, I'm not going to include the -2 because that's what sets it equal to. So I'm going to use a parentheses. Union, same sort of idea. I'm not including 3 because that's what sets this equal to 0. So I'm going to put a parentheses instead of a bracket starting at 3. So parentheses 3 to positive infinity. So all these x values. So those are all the x values that would give us a solution that our equation f of x is greater than 0. So similarly, we would do the same thing if we were looking at it for less than 0. You would be looking at the x values that gave us the piece of the graph that fell below the x-axis, or when our y values are negative. So let me just reread that or read that now. So if you're solving an inequality, ax squared plus bx plus c is less than 0, the solution set is the values where the function is below the y or x-axis. That is where f of x is less than 0. So that's one way to do it, and that's looking at it graphically. The other way to do this is to look at it algebraically. And so if we're looking at it algebraically, we also want to rearrange our inequality to get everything to one side of our inequality if it's not already done so. So rearrange the inequality so that 0 is on the right-hand side. And then we're going to look at our quadratic on the one side, ax squared plus bx plus c, and we're going to solve it when it's equal to 0. Then we're going to use those solutions to divide the number line into intervals. So these are what I call critical numbers, the values that set it equal to 0. And so we're going to place those critical numbers on our number line. And then we're going to test on each side of our interval. So we're going to choose values on each side and plug it into our inequality and see if it's a true or false statement. And so that's why we're determining the sign. So if we plug it in, is it going to be bigger than 0 or less than 0? So determine your solution set. If you're using an inequality x squared plus bx plus c is greater than 0, the solution is the interval in which the function is positive, where f of x is greater than 0. If you're solving the inequality where it's less than 0, the solution is the interval in which the function is negative. Okay, so now knowing those two methods, or recalling those two methods from the past course, let's look at them. So the first example in front of us says, solve the inequality involving a quadratic function. Solve the inequality negative x squared plus 8 is greater than 2x using both methods above. Okay, so let's get everything to one side of our inequality. Let's just do that. So let's get everything to one side of our inequality. And if we subtract 2x, we get negative x squared minus 2x plus 8. Now this is greater than 0. So I technically prefer, I don't know about you, but I prefer 1x squared. And so I see a couple ways I can do that. I could have gotten everything to the other side of the inequality, or I could multiply through by a -1 on both sides, or divide through by a -1. The only thing I have to worry about when I'm doing that is that I need to flip my inequality. So let's just do that. So I'm going to change this because I'm going to multiply by a negative. So instead of greater than, this is now going to become a less than sign. So I'm multiplying through by -1. And so this is x squared plus 2x minus 8 is less than 0. I'm going to use the second method because that's normally how I teach this way. And so we want to find the values which set this equal to 0. So we want to solve when x squared plus 2x minus 8 equals 0. So looking at this, I see that it's factored, or can be factored. So that is the method I would use to solve. There are two numbers that multiply to -8 and add to 2. So that would be a +4 and a -2. So this is x plus 4, that quantity times the quantity x minus 2. So solving this, setting each factor equal to 0, we get x is -4. X minus 2 is equal to 0 and x is equal to 2. So those are my critical numbers, and these are the numbers I'm going to place on my number line. These are the numbers that set the whole equation equal to 0. And so now we want to test our intervals. We want to see, is the value on the left of -4, is that going to spit out a positive number or a negative number? And so let's choose any number to the left of -4, and it doesn't matter. So I normally choose smaller numbers just to make it a little easier. So let's choose x equals -5. So if we go back in here and plug it into this function, I normally plug it into my inequality and ask myself, is that a true or false statement? The directions that we were just reading through says, let's do a sign analysis. So if we plug this into x, we would get -5 quantity squared plus 2 times -5 minus 8. So -5 quantity squared, that is giving us back 25. 2 times -5, so -10 minus this 8. So 25 minus 10 is 15, and 15 minus 8 is 7. So a number on the left-hand side, all our x values to the left of -4, these give us back a positive number. To me, I would have carried down that less than sign, less than 0 up here, and I would put a question mark. Is 7 less than 0? And to me, this would be a false statement. I'm not going to include that in my solution set. So now you want to choose a number that falls in between -4 and 2, not including those values. And if 0 is in that interval, that's always the easiest one to choose. So let's choose x equals 0. So if we go back in and we plug that in wherever we see an x, we want to see, are we getting back a positive, negative, or negative number? Or you can look to see, are we going to get back a false, true or false statement? So notice this, when we plug in 0, we get -8. -8. And so that's a negative number. But if I'm looking at it, is it less than 0? To me, that's a true statement. So now one more number we need to choose, anything that's bigger than 2. So let's choose maybe x equals 3. And again, we're going to go in and plug in 3 wherever we see an x. So we have 3 squared plus 2 times 3 minus 8. Is that positive or negative, or is it a true or false statement? So 3 squared is 9 plus 2 times, actually that should have been a minus. No, it's not. Sorry, I was looking above. Okay, I just want to make sure I wasn't writing that down wrong. So 3 squared is 9 plus 2 times 3, so that's plus 6 minus 8. So is that a true statement? This is 15 minus 8, which is 7. 7 is a positive number, less than 0. So this is false. And so the solution set in here would be the values from -4 to 2. And we can test it, right? Any number that falls in between -4 and 2, if we plug that into our equation up here, or inequality, we should get a true statement. And so let's just test 0 again, because 0 falls in the number between -4 and 2. If you plug in 0 for x, we get -0 squared, 0 plus 8. So is 8 greater than 2 times 0? Is 8 bigger than 0? And it is. We could test numbers outside of that and show that we would get a false statement. So we found our solution using algebra. So it also wanted us to look at this by looking at the graph. And so looking at the graph, again, we wanted to get everything to one side of the inequality. And so let's just do it where we added x squared to both sides and subtract 8 on both sides. And if we do that, we would have gotten 0, right, is greater than x squared plus 2x minus 8. I tend to like my equation on the left, so I'm just going to rewrite that, just making sure that my inequality is facing the correct direction. So it's a less than with the quadratic 0. We already did the work where we found our x-intercepts, right? We set this equal to 0. And so we have x-intercepts at the points -4, so -4, 0. And at x equals 2, so 2, 0. We can see what our y-intercept is. Our y-intercept is at -8, so 0, -8, plugging in 0 for x. And let's quickly find out what our vertex is. And so let's just do -b over 2a. And so b is 2, so -2 all over 2 times a, which is 1. This gives me back -1. Let's go back in and look for k. So K is going to equal the value. If we go back in and plug in -1 wherever we see an X, we want to see what that value gives us back. So -1 quantity squared is 1. 2 times -1, so that's -2 minus 8. So -10 minus, or sorry, 1 minus 10 is -9. Okay, so using the information I just have, we found that we have a vertex at -1, -9. Oops, I didn't mean to erase that. So -1, -9. We had X-intercept at -4. And at +2. And we found that Y-intercept was at -8. And so if we look at the graph, this looks like this. For our inequality, getting everything to one side and keeping it in the correct direction, this is telling me I'm looking for my function for all my Y values, which are smaller than 0. So everything that falls below the x-axis. Well, everything that is below the x-axis gives the x values that give me are everything between this -4 and 2. And so my solution is going to be not including, because I don't have the equal to piece on my inequality. So parentheses -4 to 2. Or another way to state that is -4 is less than x, which is less than 2. So that's how you would do it, by looking at graphing it. So we showed it both ways and we got the same results or same answers doing it each way. So there's one more example. Let's see if we can get through it. Solve the inequality. X squared plus 3x minus 28 is greater than or equal to 0. I'm going to do this graphing just because we were looking at graphing earlier today. Although now I'm looking at it, maybe deciding I shouldn't have done that. Okay, so let's find out when this is equal to 0. So let's find x-intercepts. We're looking at this function f of x equals. And so x-intercepts, this is when x squared plus 3x minus 28 equals 0. Okay, so this factors. So x plus 7 all times x minus 4 equals 0. Solving each factor equal to 0, we get x plus 7 is 0 when x is -7, and x minus 4 is 0 when x is 4. Okay, so far we have our x-intercepts. Our y-intercept, that's going to be way down there, isn't it? Is -28. So looking at f of 0, -28. I should have just done some different intervals than just one. Okay, so 28 negative. And I need my vertex. And so I can use my vertex formula, or I can complete the square. Let's use our vertex formula. So H is negative B, so -3 all over 2 times A, which is 1. So this gives me -3/2. I need to look at what f of -3/2 is. So -3/2 quantity squared plus 3 times -3/2 minus 28. So -3/2 times -3/2 is 9/4 minus 3 times 3, so minus 9/2 minus 28. I really need a common denominator. I see that it's 4, so I have 9/4 minus 18/4 minus so multiplying this by 4 over 4, 28 times 4. So 112/4. So 9 minus 18 minus 112. And that gives me -121/4. Which gives me -30 1/4. Okay, so just estimate it. So about -30 1/4, and that was -3/2, so it's -1.5. So about right here. It's not a huge deal because I'm really curious about where is this falling above and below the x-axis, depending on my inequality. And so now we have the graph. And we were looking at when is this inequality greater than or equal to 0? And so looking at the x values that give me the graph above the x-axis, I see that those are values coming in from -∞. And this has equal to part. So this is telling me I'm going to include the value that my x-intercept. And then we have, so -∞ to -7, and then +4 to infinity. So -∞ to -7 bracket union 4 to bracket 4 comma infinity. Okay, so let me see if there's any questions. If not, that is the section for 4.5, solving quadratic inequalities. And you can do it either graphing it and seeing if it's above or below the x-axis and the x values that give it to you, depending on if your inequality is less than or greater than, or you can do it the algebraic method.